So today we're doing solving linear trig equations, and tomorrow we're going to do solving quadratic trig equations. But they're very, like you would have done this in grade 11, solving the linear equations. So it's the same idea, although we've got a few new identities like compound and double angle that we can incorporate into it. But it's the same idea. And then quadratic, which is brand new, but it's really like exactly the same as solving a quadratic that you learn in grade 10, okay? It's not really harder. The trickiest part is understanding, I would think the trickiest part is understanding that like the cos x is like your x. That's what you're trying to isolate. And then you're just gonna go shift cos, or if it's like a nice one that you can find the exact value of, then do that. But if it's anything else, like what is, and I think part of the problem is if the bigger picture of the stuff hasn't clicked, then that's where people get themselves into trouble. So let me back up and let me talk about one thing before we go forward with this. Cos, let's say I get this, sine x equals 2 over 7, or sine x equals 0.34. I think people forget what this really means. We forget what sine, cosine, and tangent are. They're ratios relative to an angle. If I use SOHCAHTOA backwards, what this is asking is the angle if that side length is 2 and that side length is 7. Right? That's what it's asking for. This one's asking if this side length is 34 and this one's 100. Like I just took that decimal and broke it, turned it into a fraction, right? That's a possible fraction. I could reduce it, but same idea, right? 34 over 100 is like 0.34. So it's the same thing. Whether it's a decimal or a fraction doesn't matter, right? And then similarly, what if I had sine x equals, so if I'm solving one of these equations and I get something like this, 7 over 3. Well, that's not going to work. How can I have a side that's opposite be 7 and the hypotenuse be 3? That won't make any sense. From grade 10, we know this. Okay? So we also know a little bit about this from the graph of sine and that sort of thing. So when you get that, sine x equals this, and then you do shift sine of 2 over 7 to find the value of x, like what are you finding? Remember that it's a ratio that relates the angle, and think about, I guess, what it is you're actually doing there, because I think people kind of get lost in that part of it. So if cos x is like our variable that we're trying to isolate, but then in this case we're going to have some extra steps. We're just going to go ahead and do that. So how would you do this if this was, let's say, 3 times y plus 2 equals 7, right? I would distribute the 3 through. So this is going to be 3 cos x plus 6 equals 7. Subtract 6 from both sides. 3 cos x equals 1. Cos x equals 1 over 3. And this is why I wanted to talk about the triangles, those SOHCAHTOA triangles a little bit, because people think that cos x always has to equal pi by 3 or pi by 6 or 4 pi by 3 or pi by 2, or those special angles that we see in the special triangles, or that give us exact answers. But that's not true. It doesn't always have to be a perfect one with a pi in it, right? Cos of x could equal anything, and then we just interpret what that means. Some cases it might not be possible, but in some cases it is. Cos of x can be a third. That's fine. So what does that give me? X equals shift cos This is in radians, so 1.2. Oh no, this is supposed to be in degrees. Ooh, whoops. So in degrees, careful, because I got to switch my calculator over. I don't remember how to do that. Mode, degrees. There we go. Shift, cos. And it says to the nearest degree, so that is 70.5 or 71. I'm going to keep a decimal place for now, 70.52 or 53. But we also know that from the unit circle or from the graph, where is a third? So if this is 1 here, a third is here. Positive 1/3 is here. In one cycle, from 0 to 360 degrees, there are 2 solutions. I found the first one in the first quadrant. That's where cosine is positive. How do I find the other one? Okay, and x equals, so it doesn't come out in the equation, but I have to know that that my calculator only gives me one. Like remember in grade 10, when you first learn that there's actually 2 solutions to every square root. And so quadratics have 2 solutions. But quadratic equations by design give you the 2 solutions, plus or minus 4 or whatever they are. Right? You end up with 2 solutions when you solve properly. This one doesn't. It only gives me one. I have to know that there's 2 solutions. So this is 360 minus 70.53. In this case, that's what it is. Not always 360 minus. It's that way because it's cos. Whoops. Which is 289. So my solutions are x equals 71 and 289. Okay, so that was with degrees. Now we're back into radians, so I'm going to fix my calculator again. All right, go. Start isolating for cos of x this time. I'm sure that you can do this. This one's very similar to the last. We just don't have to distribute. We good so far? Cos x is negative 1/2. And now this is just a question from the last unit. You would have seen a question like this. Just the fact that it's a linear quadratic equation is irrelevant. It just meant we had a little bit of work to do first. But it's the same question you would have had in unit 6, where now I have to figure out from 0 to 2 pi, so one cycle or one revolution of the unit circle, where are the possible answers? What angles would give me cos x equals negative 1/2? So that's that's a special triangle angle, right? And we're still talking about cast here. So cosine is negative in those two quadrants. So it's going to be 1 over 2, or 1 over 2, those two angles. It's not a very good drawing, sorry. So you might think about, it's funny, like we do this in Unit 6, we talk about the related angle. So it'd be pi by 3. But we kind of don't do it as much, I guess, in this stuff. So it's going to be 2 pi by 3 and 4 pi by 3. So this one here is 2 pi by 3, and this one's 4 pi by 3. And you can check that on your calculator very easily. Why not? And you could even do a left side, right side check. 2 times the cos of 2 pi by 3 plus 3 should give me 2, if I work all that out. Okay? Everybody okay with that? All right, well, there's really nothing tricky here aside from that, like wrapping your head around the fact that you're trying to isolate, in this case, sine x or cos x, and then just doing the same stuff we were doing before. So I'm going to add 3 to both sides. And I'm going to subtract 3 sine x from both sides. 4 sine x minus 3 sine x, that's like 4y minus 3y. So that's just sine x, and negative 2 plus 3 is 1. Where's sine x equal to 1? Right here. That one only has one answer. Questions? Are we okay? Two more examples. What is different about this one? It's got a square root, yep. And Vivian? It's a double angle. It's cos 2x, not cos x. How in the world do we do that? There's if you can wrap your head around the fact that like cos x, cos 2x, it's all the same thing. Like that part doesn't matter, not yet. I have to isolate for the cos part. So this is like cos of 2x, okay? That's one thing altogether. So I have to isolate that first. So I'm just going to move 2 over. Forget about the fact that it's cos 2x. In fact, if you want, you could do this. Cos of like y, where y equals 2x. You know what I mean? Like you could replace that in your head, or you could do it on paper, but think about it as just cos of y, cos of one thing, whether it's 2x or 3x or 10x, Doesn't matter. We're isolating for that. Now I do shift cos, and root 3 over 2 is, again, in a special triangle. So the cosine, what would that give me? Pi by 6, thank you. But if you look at the last examples, it was x equals pi by 2, x equals pi by 3 right up there, or 2 pi by 3 when we take the negative into account. But this one is 2x equals. That's all. Right? And then divide both sides by 2. Yeah. X is pi by 12. What other angle? So cast in the second quadrant, so then I also get 2x equals 2 pi minus pi by 6, right? My related angle. Everybody okay with that? So that's 12 pi by 6 minus 1 pi by 6, that's 11. I always do that. 11 pi by 6. Happy with that? Put your pencil down and watch. There's one problem here. What is cos 2x? That's a cosine function with a horizontal compression. So if this is 2 pi, here's what cosine would look like, something like this. So cos 2x would look like this. It would go twice. So root 3 over 2, which we'll just estimate to be somewhere around here. From 0 to 2 pi, that was our range, right? How many solutions should we have? 4. Does everybody understand that? Like when you see it, it makes sense. But you'll have to just remember, and I think thinking about the graph is a good way to do it, but whenever you have a double angle, that's also like a compression, right? Or triple angle, or if it was half x, same thing. Like it has an impact on the graph, and so it would have an impact on how many solutions you would have. Literally, solutions to equations, we saw this in what, unit 4 or something like that. Solutions to equations is literally, if you think about both sides of the equations as functions, it's where those functions cross, right? It's like solving a system. That is what solving equations, like it's the same idea. So there has to be 4. So what did we find? We found the first 2, there and there, like in one rotation. So how do we find the other ones? But not 360, because that's not our period.
Oh, sorry.
But well, and not even 2 pi, but 1 pi, right? In this case, because our period is pi, to get to the next point on that graph, you add a period. Why is our period pi? It's normally 2 pi, because it's compressed. So it's a half period. So you add pi. But like not every question is the same. It's not like every question I just add pi. What if it was cos 4x? Then you're not adding pi. You'd have a whole bunch of solutions, and you'd have to add something different to find every one of those. It's a little bit tricky. Okay, so then x also equals pi over 12 plus pi, and x also equals 11 pi over, oh, this should have been over 12, sorry, I didn't finish this one, because it's 2x, right? So x equals 11 pi over 12. So then pi, or x also equals 11 pi by 12 plus pi. So this one's 13, and this one is 23. And because we get so many solutions and they're kind of like as best as you can, try to keep your solutions organized and try to keep stuff together, even just for yourself. But we usually summarize. See, do it every time. And the textbook asks for them to 2 decimal places, but a lot of the questions work out exact answers like this. So I would do them as exact answers. Great practice. That's something that I would maybe expect on a test, that you could do it as exact answers, but the textbook likes them in decimals. So if you can do it as exact answers, do it that far. And then below it, just do all the decimal answers. Just divide, right, on your calculator to get the decimals right below it. All right, one more here. So this one's got a double angle. What's different as well? It's got a reciprocal ratio. Cosecant. This is like a grade 9 skill. If you wanted to see the long way of doing it, you could do it off to the side. But basically, if you're flipping one side, you flip the other side. So cosecant is like, in fact, we could do this once. So 1 over sine of 2x equals 1 over 3. But normally I would just say, so sine 2x equals 3 over 1, right? Or 3. So you flip both sides to get it into one of the primary ratios. Okay, so when is the sine of 2x equal to 3? Shift, so that's not one of our regular ones, so shift sine. Do that on your calculator. Somebody give me the answer. Nathan, what'd you get? Yeah, of course you got an error. Sine can't be 3, right? It's funny how we get into this autopilot, right? But think, it really, really helps to think. This is 1. When will sine ever get up to 3? It doesn't. So this is no solution. Any questions? Questions. I think we have one more, but you don't even really have to write this down. How many solutions would cos... Oh, this is a terrible question. It's not supposed to... 0 solutions for the same reason, but... oh, gosh. Let's see. How about equals negative 1/2? How many solutions would cos 3x minus 1 equals negative 1/2 have? Without, we're not even going to solve it, just how many solutions would it have? 6. Does that make sense? Because you're compressing it, you're compressing the regular 1 period up to 2 pi, right? If it doesn't say that actually, it shouldn't even say that, but if it's 0 to 2 pi, you could fit, it's a compression by a factor of 3. So you're going to fit 3 cycles in to between 0 and 2 pi. So you're going to get two solutions. It's going to work out to, when you add one to both sides, positive a half. So cosine of positive half, we can find that. That's fine, right? You're going to have two solutions to that in the regular unit circle. But that's going to happen 3 times. So see what I mean? Every question is a bit different. And you're not just going to add pi to get the next ones. In fact, adding pi would make it wrong. You're going to add something else. You'll find the first two the normal way. What would you add to find the next two? There's one question I think in the practice that's like that, so I'll let you think about it. Any other questions? Are you okay? Make sure it's clicking for you. That like people get caught up, your brain gets caught up on this sine x like it's somehow different from solving an equation like this. 2x plus 4 equals 10. It's that easy. These are elementary school questions. Except they're not, because that sine x, it is hard to abstractly realize that sine x is a thing. Please never do this. 2 sine x equals 3. X equals 3 over 2 sine. Oh my gosh. Right? You don't pull the sine away from the x by like dividing it or something like that. Oh my goodness. Right? So isolate the sine x like it's your variable. Whether it's sine x, 2x, 3x, sine 2x, sine 3x, whatever. And then shift sign to get rid of that part. And then whatever you're left with, you're just kind of